Audio Jungle. Audio Jungle.
A turbofan engine is powering an aircraft flying at Mach number of 0.9 at an altitude of 33,000 feet. Okay, where the ambient temperature and pressure are minus 50.4 degrees Celsius and 26.2 kilopascal. The engine BPR BPR means bypass ratio is 3, and the hot airflow passing through the engine core is 20.7 kg per second. Okay, preliminary analysis provided the following results. Okay, what results they have given to us? They have given the value. Okay, means for all the details for the turbofan they have given us fuel air ratio, which is 0.015. They have given P cooled, it is 55.26 kPa. V cooled they have given 339.7 meter per second. AE cooled they have given area 0.299 meter square. Now coming to hot nozzle detail, they have given 32.56 kPa. Okay, V hot 452 meter per second, and AE hot they have given to us is 0.299 meter square. What need to find here? We need to find thrust force. Okay, this is the question. So see this question very nicely they have elaborated. I mean the question description they have given very nicely. Such type of problem they can ask, they will give each and every detail, nothing to worry. For exit pressure for both nozzle cold and hot they have given, exit velocity for cold and hot they have given, area for cold and hot they have given, fuel air ratio they have given small f which is 0.015. Okay, and rest detail like where the aircraft is what flying, so there you can get P infinity and T infinity somewhere required, because Mach number they have given, so definitely V infinity you will get from Mach number. So T infinity you have minus 50.4 degrees Celsius, you convert into Kelvin, so you will have a V infinity where the aircraft is what flying, and with that speed the aircraft is what flying. So all detail here actually given. Only the thing is you should know the formula and you need to put that value, this value in the formula, that's all. That is the only question. So such type of problem they will ask, because here the more than 50% problem they have solved it itself, problem itself has given the solution. Only your job to do complete 50%, means write the formula, fill all the data, that's all, you will get answer. So check, you can say now see your aircraft is not flying here. Okay, this aircraft is having a turbofan engine, and here the altitude is given 30,000 feet, 30,000 feet, but nothing to worry. Why? Because the value of the pressure and temperature directly they have given, so no need to calculate. Like in previous problem you had calculated that value, but here they have given what? Infinity, how much it is? Minus 50.4 degrees Celsius, minus 50.4 degrees Celsius, convert this in Kelvin, minus 50.4 plus 273, 222.6 Kelvin. Okay, and P infinity also given how much? 26.2 kPa. This detail they have given to us. Now coming to turbofan engine. Okay, so for this aircraft, now coming to turbofan engine, so I had explained nicely. In short, I will show you that turbofan once again. See, this is the gas generator, you can see. In gas generator, what I will show? I will show you this compressor and turbine. Okay, and here the fan is what connected with this. You can say okay. This is the low pressure turbine. Yes or no? Okay, and this is the high pressure compressor. So this is connected with the high pressure turbine. Okay, so now this is the turbofan engine, right? Whatever the air is what coming here, m dot a, now it is converted into m dot cold, and whatever the air is what passing here, it is m dot hot. Here the velocity will be, and here the velocity, it is VE hot, it is VE cold, that you know. Okay, so whatever the area here, it is AE cold, and what is the area here, AE hot, that you everything you know. What is the BPR, bypass ratio, it is beta, which is m dot C divided by m dot H. C for cold, H for hot. Now we can have the whole scenario, all the data they have given. Now we'll write the formula directly. Okay, so whatever the data required, accordingly formula we can get. So we'll write here thrust equation for turbofan engine aircraft. What is the thrust? Thrust is equal to focus, na? M dot wait. We'll write for the cooled and hot nozzle separately, na? So I can say we will write thrust due to hot nozzle plus thrust due to cold nozzle. So for hot nozzle, directly I am going to write formula, please try to connect it, na? So it will be m dot H 1 plus F VE hot minus V infinity, okay, plus PE hot minus P infinity into AE hot, plus now going to write for the cold. So in cold nozzle m dot cold, but we do not have fuel injection in the cold nozzle, so this 1 plus F term will not be there, but rest velocity component will have VE cold minus V infinity plus PE cold minus P infinity into AE cold. Check all what we do not have. Mach number they have given to us. We do not have V infinity. Na? Rest everything we have. Rest each and everything we have. See, only V infinity is unknown. What is V infinity? It's the aircraft speed. How to get that? Mach number they have given, M infinity is equal to V infinity divided by root of gamma r P infinity, speed of sound. What is the V infinity? So we can write M infinity gamma r T infinity. What is the Mach number? I think 0.9. No? Mach number is 0.9, right? Yes, 0.9, 1.4, 287, temperature is 222.6. If you calculate, what you will get? 1.4, 287.222.6. Take root of it, multiply it by 0.9. How much we are having? 1.4 into 287 into 222.6 root, it's a 269.15 meter per second. So now V infinity we have, please in the formula you write all the value, because fuel air ratio they have given us, each and everything we can write. So we'll get the thrust. Start putting all the value. M dot hot, that value they have given to us or not? What they have given to us? Wait, BPR they have given, and they're passing through the engine core is, means this is what? M dot hot, 22.7 they have given to us. Okay, so this M dot C and M dot H we need to calculate. So let me complete this part also. Wait, don't be hurry at last moment, just have a patience. So BPR M dot C divided by M dot H. From here M dot C means cold is equal to BPR M dot hot. Here it is clearly mentioned. Wait, here it is clearly mentioned. Check what they said. The airflow passing through the engine core. Engine core means hot air, right? So 22.7 kg per second they have given. 22.7. So I can say M dot cold is equal to, what is the bypass ratio is mentioned? Bypass ratio is given 3 into 22.7, right? 3 into 22.7. How much you have? 3 into 22.7, it is 68.1 kg per second. So you have this M dot C also cold, and M dot H they have given to us. Okay, M dot H they have given 22.7. Now in the formula you keep all the value. So thrust is equal to, I'm writing the value. So check, M dot H is 22.7. So in the formula, okay, M dot H 1 plus F VEH hot minus V infinity. Na? So I will write 22.7 in bracket 1 plus F they have given to us 0.015, I think, na? 0.015, right? 0.015, 0.015 VE of cold in the problem. If you check, it is given. Now check the detail. So VE of hot, we are writing VE of hot. So check the detail here. Take a screenshot and then proceed ahead. So better. VE of hot, how much? 452. So all the value here it is given. Only the thing is now you have to keep in the formula. That's all. 452. Just now V infinity you have calculated. You have calculated how much? 269.15. 269.15. This is the momentum thrust. What is the pressure thrust for the hot? So PEH. See PEH. What is the value of PEH? 32.56, right? 32.56. It is given in kPa, na? 32.56. It is given in kPa. So that we need to take care. Okay, we do not have to commit mistake. 32.56 it is given. 32.56 kPa they have given to us. so that unit should be perfect, otherwise you will suffer, na? So 32.6 EH minus P infinity, just now you have calculated. How much you have calculated? Check. It is KPA. KPA value is 26.2. Huh? 26.2 is the P infinity. So 32.6 minus this value you have 26.2. 26.2. Okay, it's the kPa value, so multiplied by 10 power 3. This is the pressure. And what is the hot nozzle area? AE hot. AE hot is nothing but 0.299. 0.299. Okay, 0.2. So this is the hot nozzle coming to the cold nozzle. So cold nozzle mass flow rate m dot c, just now you have calculated. M dot c is 68.1. 68.1, right? So you can write 68.1 mass flow rate of the cool nozzle into V exit of the cool nozzle. What is that? It is 339.7. Huh? 339.72, and what is the velocity? 269.15. So you can write 339.72 minus 269.15. This is the momentum thrust. What is the exit pressure of the cool nozzle? Check. It is nothing but exit 55.26. 55.26. 55 point minus P infinity is given 262 point into 10 power 3. What is the area of the cold exit? It is 0.299. That's all. Solve it. If you solve this value, check this. So all the data I have filled only. This is what hot nozzle. Okay. There should not be any confusion. This is what hot nozzle, and this is what cool nozzle. Okay. Now you calculate the value.
Now this problem number 4 we have. Okay. Problem number 4. Here the problem is an aircraft. Okay, an aircraft flies at a speed of 520 kilometers per hour at an altitude of 8,000 meters. The diameter of the propeller of an aircraft is 2.4 meter and flight to jet speed and flight to jet speed is 0.74. Find the following. Find the following. Number one. Number one, we need to find the rate of airflow, the rate of airflow through the propeller, propeller. Number two, thrust produced. Number three, specific thrust. Specific thrust. Number four, specific impulse. Number five, thrust power. Okay. So here in the question, they have given a propeller of an aircraft, right? That dimension of that propeller diameter is given 2.4 meters. So this is basically turboprop problem. Okay. Now for this aircraft, you can say here okay, and if I assume it is a turboprop engine aircraft, because here it is clearly mentioned it is having a propeller, right? So we can say this is what all right. So in this case, if you check, say this is the air. Okay. Now air is what going like this. Here we have a combustion chamber, and the air will be exiting here. This is VE, and whatever the velocity here it is, V infinity. Okay. And check the propeller diameter they have given to us. Okay. Propeller diameter they have given to us. So now the propeller diameter they have given propeller diameter D, it is given how much? 2.4 meter. In the problem itself it is given. Okay. So here we can get area of propeller area of propeller AP. It is pi by 4 b square because it will make circular disc. So pi by 4 into 2.4 is square. So how much you may get? You will have a 4.2 meter, 4.52 meter, right? 4.52 meter. This is the area of the propeller. Now here in the problem itself they have given speed ratio. Check in the problem. In problem itself they have given a speed ratio here. Speed ratio is 0.74 and that speed ratio is nothing but uh, flight to jet. No? Flight to jet speed. So flight to jet means V infinity is the flight speed and jet speed is nothing but VE. So actually here it is given speed ratio they have given flight to jet means V infinity divided by V, it is given how much? 0.74. Okay. Alright. Now the first question they had asked the rate of airflow through the propeller. So jet velocity they have given to us. Okay. And inlet velocity is given V infinity and exit velocity is given VE. Okay. We can get that. So what is the VE? VE is nothing but V infinity divided by 0.74. What is the V infinity? You can check here. V infinity is nothing but 520 kmph. So V infinity is given 520 kmph, kilometer per hour. We can convert it into meter per second. So what will be the velocity? Velocity will be 144.4 meter per second. This is the V infinity in meter per second. Okay, so here we can get V exit. If you calculate 144.44.74, so this value will be how much? I am getting here 195.19 meter per second. Okay. Now this is the value. We'll go for the propeller. Okay. So for this propeller, this is the V infinity and somewhere here it is jet velocity VE. Okay. VE. So as per propeller theory, what you will say? Velocity of airflow at the propeller will be V average. Okay, and this V average is nothing but V infinity plus VE divided by 2. So what is the V infinity? V infinity is nothing but 144.44. What is the V infinity? V exit 195.19. Okay, divided by 2. So you will have a V average, and this value you will get 169.81 meter per second. to get the mass flow rate of air. Okay. So m dot is equal to rho a v average. That density in the problem, check, it is not mentioned. Actually, that value they have given to us. In the problem itself, the mass flow rate is given. I had not mentioned. If density is 0.525 kg per meter cube. Actually, at this because the aircraft is what flying, okay, at altitude of 8 kilometer. So if you calculate density, so you will get 0.525 kg per meter cube. So if you want, you can calculate this value also given. So I have mentioned there. Okay. So this value is 0.525. Area just now you have calculated here. This area is nothing but 4.52 disk area of the propeller. Okay. It's a 4.52 into average velocity 169.81. So if you calculate m dot, sorry, m dot will be 402 kg per second. So this is the mass. Okay. This is the first value. Now we'll go for the thrust. So thrust produced okay. If you go for the calculation of thrust, so we can write the formula. Thrust is equal to m dot 1 plus f ve minus v infinity plus pe minus p infinity into a. Okay. The pressure thrust we can neglect because not a single data they have given to us, so we cannot calculate that. And most of time, if it is turboprop, so obviously thrust you will get momentum thrust. So because it is fully expanded cases almost, so you can consider that pressure thrust will be zero. So you will have a momentum thrust, and in fact fuel air ratio they have not given, so we can assume it is zero. So this value will also be considered as zero. So what will be thrust? M dot A Vp minus V infinity. Just now you have calculated m dot A 4.402.96. Ve you had calculated 195.19 meter, and V infinity was 144.44 meter per second. Yes or no? So if you solve this, then first you will get 20.4 kilonewton approximate. Okay, this is the specific thrust. Okay, So next is here thrust you had seen 20.45 kilonewtons. This is the thrust. What is the specific thrust? Simple. Specific thrust is nothing but Fs thrust divided by mass flow rate of the air. If you do this, so thrust you had calculated 20.45 into 10 power 3 kilonewton divided by what is the mass flow rate given? You had calculated it was 402.96. If you do this, then you will get 50.75 Newton second per kg or Newton by kg per second. So this is the Fs, which is nothing but specific thrust. Now we'll go for the third. What is the third? Specific impulse. Specific impulse, it is noted by ISP. So ISP is nothing but thrust force divided by mass flow rate of air into G. Actually, it's a mass flow rate of the propellant in case of the rocket. Fuel mass here you have neglected because they had not given, so you had neglected that. So you are writing here m dot A. Okay. What is the thrust? 20.45 into 10 power 3 divided by what is the m dot A? It is 402.96 into G 9.81. Until unless they have not given, don't take 10. Okay, otherwise answer will vary. If you solve this value, so ISP solve it, then ISP will get is to solve this, then you will get 5.17 second. Unit of the ISP is specific impulse is second. You can check that unit is second. Okay. All right. So now what is the thrust power? Last fourth number. So fourth number is nothing but thrust power. It is nothing but thrust power TP. Okay. What is the formula of TP? Thrust power is nothing but thrust into velocity of the aircraft, which is nothing but V infinity. So thrust you have seen here, it is 20.45 into 144.44. If you solve this, then you will get thrust power. Okay. If you solve this, then you will get 2.95 megawatt. Power unit is watt. If you solve this, you will get mega. So this is the problem. Okay, done.